Hello, in this video I'm going to show you what the derivative of the sine function looks like. So a derivative is a gradient function, and so I need to find the gradient of this curve, how it changes as I move along the curve. If I'm going to get that, I need to have a point that lies somewhere on the curve. So I'm going to put a point on the curve. There it is, the point A, and I'm going to draw a tangent to the curve at the point A. So I click on the tangent function, pick the point and the curve that I want the tangent to, and there we've got the line that's tangent to that curve. I'm just going to make that line a little bit thicker so it's a bit more obvious for us to see. There it is. So we've now got the tangent to the curve, and you'll see that as I move this along, so that tangent is going to change its position. It'll be useful to know what the slope of this line is, so I can click on the slope function, and there I've got the slope of the curve, and you will see as I move it along so the slope changes till eventually it comes parallel to the x-axis and then keeps going down. So I can get the slope of the curve. Now what I want to do is I want to plot what the gradient is doing at every point along this curve. So I'm going to call this point, I'm going to call a point D for derivative. I'm going to say D is going to be the point that has the x coordinate of A, of point A, and I'm going to plot it with M, the gradient of the graph over here. And if I do that, we'll see there we've got the point D over here. That has got the gradient and it's got the same x value. If we could look at them over here, we've got the same x value and D has the gradient, which is this function over here. Now let's see what happens as I move this line along. So as I move up to the maximum, we'll see that the gradient is getting lower and lower and lower and lower and lower until eventually it's going to cross the x-axis. And then it starts becoming negative as the slope decreases. Now it'd be quite useful to see what's happening here as I move this curve along. So what I'm going to do is I'm going to put a trace on this point, and then I'm going to run it. And I can animate this point by, let's put it back here at the origin. I can animate this point just by clicking on it and running an animation. And we'll see that the curve goes and plots all the gradients of this function. And so we can see that the derivative of the sine curve is actually going to be a new type of curve, and that curve should be fairly familiar with us because it's the cos curve. Now I need to try and get this animation to turn itself off, so I'm just going to go into point A and I'm going to stop the animation. So we can see now that the gradient of the sine curve can be plotted as the cosine curve. And so here is the first of our derivatives that we can come up with, and that is that the derivative of sine x with respect to x is going to be cosx. And you'll find this in your notes. Now, I'm just going to change this original function that I had over here, and I'm going to change it from sin x, and I'm going to change it to cosx. And we know that that's the cosx curve, and I'm just going to scroll this out, and we've now got our cosine curve. Move the point A back to where x is 0, and I'm now going to plot and see what happens as I move this point along the cosine curve. What will my derivative look like now? So I drop it down, and we will see that we're going to pick up another trig curve. It looks familiar, which I suppose is not too surprising. seeing that we know there's a relationship between sine and cos. And we can see that as I go through one full period, I'm creating a new type of graph. Let's just put the animation on this so we get the whole thing being traced out fully. And we can see that we're going to get a new type of curve. And it looks familiar. And let me turn the animation off. And it looks familiar because it looks like this sine curve. The only problem is it's been reflected in the x-axis. In fact, the curve that we've got drawn over here in black, that is actually the minus sine curve. So this is y is equal to minus sine x. I can fill that in here and say y equals minus sine of x. And you'll see that that fits on, whoopsie, no, that's wrong. Delete that. Y equals minus sine x. And we'll see that curve falls exactly on top of this function that we've got over here. So the derivative of the cos function is minus sine x. So I hope that helps you visually understand and see what happens when we take the derivative of sine and of cos. Derivative of sine is cos. The derivative of cos is minus sine. Hope that helps. Goodbye.